Hello, everybody, and welcome back to video number 34 in this series of I'm preparing some lecture notes for uh, a summer camp with high schoolers teaching game dev, and just wanted to give it a practice run and edit my notes, and decided that instead of deleting the videos, I would share them on YouTube. So we're 34 videos into the series, into the set, so a lot's been going on. Um, got our cutscenes, the storyline, our general movement, and in the last video, couple videos, we set up the basic uh, conflict animations and scripting for our gameplay. But all we did was print it out on the screen. So print out the score to determine when our uh, character had attacked the alien or beat up an alien with the little stick he's got. So run over here and whoops, not spacebar. Forgot which button I put that on. So we hit our alien and it increments our score, but it'd be nice to have a better visual cue than that. So some updates on the alien animation. I was thinking he can just fall forward because a few videos ago we set a raycast so the alien's looking straight forward to see if the character's there. So the best way to avoid that accidentally happening after we knock an alien down is to make sure he falls face first, and then that way the character's not going to be underneath him. Uh, if we rolled it backwards, the character could step on top of it and then get detected again. So I'll just do an animation where it rolls forward, and to do that, we can just check and see which direction we need to roll. So if we check that, looks like if we take the X one and look at our transform data and rotate that in the positive X direction by 90 degrees, it'll give the impression of the alien falling down after being hit. And when do we want to do that? Because when we do that, rotate it forward 90 degrees, we don't want it to still be in the idle animation or the walking animation, so we want to stop our animation. So that, from the stuff we've already done in an animation tree, hopefully you can already see when we want to do that. We'll set a transition up from our idle animation over to the end state, which means nothing else is going to run. And I'll do that on a condition of is done. That sounds like a good Boolean to use. And I'll just copy that and apply that to no matter what animation we were in. If that Boolean becomes true, then we will stop animating everything. So nothing new there. Then there is something kind of new coming in the script. It's not necessarily new. It's just something that is a little bit different in game development than other types of programming. So I wanted to focus on that mostly here. Hopefully you see this just stops our animation. If we were in the idle animation and go to the end state, we're just not animating anymore and the character will be laying down when that happens. I did rotate it back. Yeah, okay. So looks like we're ready to apply that, which is going to happen in our script. Um, so on the player script is where we hit the alien. So we need it to happen to the alien. And we'll do it right down here after we hit it. So if all this happens, it falls into this right here. We just check to see if that's empty. Because if it's not empty, then the only thing we have to hit is an alien. So whatever goes in there should be an alien, so we can rotate it 90 degrees and switch that Boolean. And at first, that's going to seem like things we've seen before. We'll set up a variable to hold it. Raycast dot get collider. Oh, whoops. Sorry. Let me set a variable. I'll call it collider is going to be that raycast dot get collider. So whatever that returns to us, and I'll just do the go ahead and infer the type. So we're like in a strictly typed language. And notice it can't infer the type. It doesn't know what that is. So sometimes we're a little bit restricted. We could set the type as an object. Um, I think it's could just set it as a game object because everything is a type object. That way we're still strictly typed. Or if there's just a few places where you need the computer to waste time figuring out what data type you have, it won't hurt. It won't hurt as much. But I'm gonna go ahead and put the object in there. And now we can we can just access that object in the collider. And well, it has a rotation property. And in particular, we can access the X component of that rotation vector and then rotate that just like we did before, like we just saw. So collider.rotation dot X. Oh wait, no, we're just going to positive 90, aren't we? We aren't adjusting it from what it is. We just automatically go to positive 90 from whatever. So these laying face down. And then we need to stop the animation. And that can be a little bit different. There wasn't a good spot to talk about something here, so I decided to go with this spot. There's kind of a workaround, but I want to talk about it here. Maybe I'll just write the line of code first. So that collider, which we know is going to be an alien, so we can access its animation tree. And that animation tree is a variable. So if we go over to the, whoops, where did our script change? If we go over to the alien object and look at the animation tree, we have this parameter for is done. Oh, I don't need the quote marks here. I can just drag that over. So I'll drag that over, and that's the one I'm going to grab. And I know this is fine, so we'll set that equal to true. I'm going to pause for a second and let you stare at that code. And anybody that's studied programming, had some programming courses, taking a programming boot camp, or just has a good bit of experience with programming, do you notice what would typically be considered a serious issue in this code? We know it's fine because that collider is only going to detect aliens. But normally, this is the sort of stuff that should go into exception handling, right? In any programming class you take in the modern world, they're going to introduce exception handling, usually very poorly. They have you stop the program and print out a message, which is what would happen if we didn't handle the exception. In actual software development careers, your exception block usually ends up being longer than the rest of the code because that is to fix the problem, not to stop the code and spit out a message, because that's what happens if we don't deal with the problem. But that exception handling. In a business situation, this would, right, some business application software where we're crunching some numbers and checking them against the database. We would want to put up some nice exception handling and try to do stuff, catch any exceptions, and deal with it appropriately so that our software keeps running. It doesn't just stop and spit out a message. That's just an abbreviation so that textbooks and tutorials don't get insanely long trying to talk about exception handling. In a real application, the exception block is probably going to be longer than the code that than the actual program. But we would do exception handling. But in a business application that's crunching numbers and checking things against the database, there's not nearly as much going on as a game engine. Exception handling, like we know it, doesn't really work in game engines. This really shows up if you're using Unity, where you're scripting in C# and you have all that exception handling that's built into C#, but it's not going to work the way you think it's going to when you run that code, because the exception handling built into C#, the syntax that's there is for like business software applications where you're crunching numbers and checking things against a database. It's not for a game engine where you have a physics engine and a game engine and a rendering pipeline and a connection to a database and all of that stuff, all of those separate pieces tied together. The exception handling isn't just usually isn't big enough to handle that. So you need to come up with more interesting solutions in your code to handle it, or be like we have here, where we are certain the collider can only see aliens. So we know for certain that anything we see in that raycast collider is only going to be an alien. So we know it's okay here. But you need to come up with more clever solutions than the exception handling. Um, I remember programming before our programming languages all had good exception handling. For example, when I learned the language R, an exception spit out binary code. There was no message. If it hit an error, it just spit out a bunch of binary code, and that's how you could tell what the error was. There was no exception handling in the language at all. And I remember programming before exception handling, like we have in most of our modern languages, was worked into the language. And we always had to do clever solutions to get around that stuff. And with game engines, you have to go back to it because there's too much going on. Um, in particular, here in this particular example in Godot, we're in physics process, which means if we did a try catch block here, or it's based on Python, so a try except block here, uh, it would um, it would notify the physics engine about it, but it would not notify the rendering pipeline, and it would not notify the overall game engine frame counter, and it would not notify the database. So the try catch blocks like you're used to aren't really going to work in game engines. And that especially shows up in Unity because we have the try-catch syntax that came from the fact that we're using C Sharp, which we can also use C Sharp and Godot, and we get the same thing there. But it's not going to notify all the parts. Like if we put it in physics process, it would notify the physics engine, but not the rendering pipeline. And if we put it in process, it would notify the rendering pipeline, but not the physics engine. So for exception handling, you have to do clever solutions like probably before most of y'all's times when before exception handling was worked into all our languages and we just had to come up with a clever solution or do things that we would be certain would not throw an exception. So I needed to work that in someplace, but you can see how we can just grab whatever that collider hits and then access those properties just like we were working over on that alien object itself. So now our thing should fall down when we hit it with the stick. Let's go try that. So make sure we're on level, run that. And instead of just, I can get a good view here. No, I think I'm going to block it every time. Oh, I keep it in the space bar. I should have just programmed it to hit with the space bar and jump with the shift key. Did I not hit it? Why is that not? Oh, nope, I didn't hit it. Oh, there we go. So that time he fell over and embedded in the ground. And I guess that was also a good example that the raycast is like a laser pointer. It goes straight out. I think it was set around the knees, so straight out from the knees. So it's off by, if it's off by an inch, we can miss our alien. So you want to be precise with that. But now we have a visual cue instead of just that score showing in the output. And before long, we'll have a HUD, probably in the top left of the screen showing the score. So we'll get back to that. But the big thing from here is that whatever that raycast detects, we can just work with that object directly. And if you've had like programming courses or gone through programming boot camps or just self-studied a lot of programming and have some experience there, the exception handling like you're used to will not work in a game engine. Even if you're in a language where you have the syntax, do not count on your try-catch blocks. There's just too much going on in a game engine to notify all the different pieces quickly enough. Try-catch blocks work in normal things because we can do that with less bits, right? We can hit an exception with as few as 1 bit, so it can take less RAM than an if block, which is a fancy trick we can do sometimes. and use try-catch as an alternative to the if-else selection structures with as few as 1 bit instead of however much data we're trying to process in that selection. But that would not work in a game engine. So that makes it quick, but there's too many parts to notify to rely on our exception handling like we're used to in business application software sort of programming. So I just wanted to make that point. Otherwise, there's not much new in this video, and I will see you in the next video. There's a lot going on here, but we are actually getting close to the end of the rough draft. I'll see you in the next video.